Hello everyone. So today we will see about current waveforms in MOSFETs. So let us take nMOS first. We'll take nMOS discharging current. So if we take a nMOS like this, this is the gate, this is the drain, and this is the source. So when discharging, we'll connect a load capacitor to the drain and the source. And the source is connected to ground, and we are applying a step input of 0 to VDD here, and let us take this capacitor voltage as VC, and the capacitor is initially charged, that is VC of 0 minus is equal to VDD. And we need to discharge this capacitor now like this, and this current is ID. So we need to draw a waveform. We need to see how ID varies with respect to time. So what happens is, initially the drain voltage VD is, that is VDS, is VDD minus 0, that is VDD, and VGS VGS is VDD minus 0, that is also VDD. So here VDS is equal to VGS. Therefore, the device is in saturation. So the current is constant, that is VGS is constant. So the current will be the current ID is constant. So after that, the in nMOS equation, the condition for saturation is VGS minus VTH should be greater than or equal to VDS. This is a condition for saturation. The nMOS should be in saturation. So if we take VGS, which is VDD minus VTH, if we take VTH of VTHN, should be greater than or equal to, what is VDS? VDS is VD minus VS. VD is VC minus 0. So we get like VC should be less than or equal to VDD minus VTH of N. So initially the capacitor voltage is at VDD. Up to VDD minus VTH of N, the nMOS is going to be in saturation region, and after that it enters linear region when VC is less than VDD minus VTH N. The nMOS will be in linear region. So the current will be, so we all know that the nMOS can completely discharge the capacitor. So if we draw roughly like up to VDD minus this is time, like up to some time, like it will be a constant current like this, because the device is in saturation. So in saturation, the nMOS acts like ideal current source. After that, the nMOS enters into linear region, so it will drop like this. Why? Because ID is directly proportional to VGS minus VTH of whole square in saturation. And here VGS is constant. Why? Because VG is at VDD and VS is 0. And now when the device enters into linear region, now ID will be directly proportional to VDS. So VDS means VDS. VDS is VC minus 0. So as the VC drops, VDS drops, so ID also drops linearly. Why? Because it is in linear region. So the ID drops like this up to 0, right? So if we draw the current waveform, we'll get like if we take an axis, this is current axis, this is time axis, this is time, this is ID. So up to certain time, which is up to this point, here the voltage will be VDD minus VTH of N. The current is constant, and after that, the current drops linearly up to 0. At this point, VDS is equal to 0. Why? Because the capacitor is discharged completely. So this is the current waveform.